Good morning, students. Welcome to science class. Today, we will be learning about mirrors and lenses. I'm sure we all know what mirrors are. We use them in our everyday life.
Hello dear traveler, just in time. My name is Chor and I need your help.
Huh? What's going on?
Long story short, all my mirrors and lenses were stolen. In order to get them back, you need to fight off 4 dangerous thieves along the path. Of course, I'll be your guide throughout the whole journey. Are you up for the challenge?
Challenge accepted!
Great! Let's get going. Let's talk about mirrors on our way. There are 3 main types of mirrors that we make use of. Plane, convex, and concave mirrors. Let's start with a plane mirror first. A plane mirror is a reflective surface that is microscopically smooth and flat.
As stated in the law of reflection, the angle of incidence would be equal to the angle of reflection. To further illustrate, the angle of incidence is the angle an incident ray forms with a normal, which is an imaginary line perpendicular to the reflective surface. On the other hand, the angle of reflection refers to the angle created between the reflected ray and normal. Beyond the mirror, the image form is situated at exactly the same distance the object is from the mirror. It is upright, and it has the same size as the object. Furthermore, the nature of the image formation is virtual, as the converging of rays behind the mirror is not present in plane mirrors.
Looks like this is the first thief. Good luck! Yes, you got my bathroom mirror back. Now, let us continue our journey. Let's discuss about convex mirrors now. A convex mirror is a type of spherical mirror that has an outward bulging reflective surface, which means that the center of the mirror curves towards the viewer. It is also called a diverging mirror because light rays spread out when reflected. The image depicted by the mirror can actually be predicted by using a certain method. This technique is called ray diagramming, which is utilized to determine the location, orientation, size, and type of possible image form of the object in front of the mirror. The main components used as a basis in this method are the principal axis, vertex, focal point, and the center of curvature. It's important to take into consideration the 2 rules we have to follow when ray diagramming. Rule 1. The incident ray parallel to the principal axis passes through the focal point after reflection. Rule 2. The incident ray passing through the focus will become parallel to the principal axis after reflection. The point at which the principal and focal ray intersects behind the mirror is where the image of the object is formed. The image formed by convex mirrors will always be closer to the mirror itself. Moreover, the image formation is expected to be upright, smaller, and virtual. Second thief, I know you got this. You're doing great so far. Now, let's talk about concave mirrors. A concave mirror is another type of spherical mirror that has a reflective surface that inwardly sinks, therefore having a center that bends away from the viewer. It is also referred to as a converging mirror, as light rays are directed to its focal point. Ray diagramming can still be applied to concave mirrors as well. First, the principal ray is displayed, which is parallel to the principal axis and reflected towards the focus. Next, the focal ray is drawn, which pierces through the focus and reflects off as a parallel to the principal axis. In this example specifically, the image is
Between C and F.
inverted, smaller, and real. The image formed by concave mirrors may be from infinity to very close to the mirror, upright or inverted, smaller or larger, and real or virtual, depending on the object's position.
And finally, let's briefly talk about lenses. There are 2 types of lenses, converging and diverging lenses. A converging lens has a bulging center and thin edges, which causes light rays to pass through it inwardly, converging the rays to a focal point. The law of refraction states that light bends when it passes through mediums with differing refractive indexes. Ray diagramming can still be applied to converging lenses. First, the principal ray is drawn, which is parallel to the principal axis and then directed towards the focus. Next, the focal ray passes through the focus and then becomes parallel to the principal axis. Lastly, the central ray pierces to the center without reflection. In this example, the image form is beyond 2F, inverted, larger, and real.